Today the topic will be software development, since Chris Mair will present us how he used Go to develop a chess engine. He is a chess passionate, a Go passionate, and so I'm really curious to hear what he did. I don't steal you much more time. Thank you, Chris, for coming here and sharing with us your experience, and the floor is yours.
Thank you, Stefano. I will try to speak without a microphone. Is this okay? Because I need both hands to use the keyboard. Okay? Good.
Switch off.
Furthermore, we are hopefully recording things. Right now, I'm just recording myself, and the audio should be understandable only from this place, so you can still move freely and you will not be on the registration, hopefully. If you walk here, you will be, so be aware of this. So as Stefano said, this evening I'd like to talk a bit about Go and about chess. Maybe a little bit more about chess and a bit less about Go, but I'm open, of course, for questions, and I will read the room and see what you like to know and try to please you. I've also brought a chess set over there, so to be in the spirit, if somebody wants to try to play, please go ahead. You can use it. I already have played against one of you. I won't name names because we both sucked, basically. So it's understandable that I moved from playing chess to programming chess. Okay, so without further ado, here is a little bit the outline of things I'm going to talk about. I did not bring with me a formal set of slides. I will just ad-lib this a little bit, as I usually do. So the outline will be about Go, about chess, just to get everybody in the context. Then I'll talk a little bit about chess engines, which is a very interesting set of programs. It's really interesting if you are a developer. Maybe you're not aware that there's so a rich community of people into chess programming. So that's the chess engine history, and finally I will introduce my humble project to write a chess engine, which I'm actually sort of proud of because it plays correctly, which is not a given. Even though it does not play very well, there's still a lot of room for improvement. Of course, we can then together try to beat it. To know if there's somebody good at chess here, probably we will manage to beat it, I guess. Okay, so let's start with Go. Go is a language I sort of discovered a few years ago. I like it a lot. It is somehow, in a certain sense, a her of C. C was one of my first programming languages after BASIC, say, and I'm kind of still a bit in love with the good old days of Kernighan and Ritchie, if you know what I'm talking about. The young people probably don't know that book anymore. And Go is, in a certain sense, the spiritual successor of that language. There's also Kernighan involved with, wrong name, Ken Thompson involved with Go, that was originally involved with Unix and C. So in that sense, it's also a continuation. Go has a few interesting things. It's very readable, very expressive. It almost reads like Python, which is a very expressive language, but on the same time it's a statically typed language, so it does not have the problem of many scripting languages that you tend to mess things up because you don't have strict and static typing. it's a compiled language, but the compiler is instantaneous. Go compiles faster than the Python interpreter starts up. I have the feeling sometimes, so you can really compile super fast. And it's multi-platform in that you can compile for every platform on every platform. So, for example, if you have a Mac and you want to compile for Linux, you can do that, no problem. You don't need the compiler on the target machine and so on. So cross-compiling is built into the language. I find this super cool because you can just ship all the binaries with one single shell script that compiles for 10 different platforms. Yeah, so when I started this project, I wanted to learn the language a bit better. So I said, okay, let's do a toy project to learn the language, and I picked up this chess thing. It is, as you will see shortly, a very nice piece of program, I think, and it somehow showed that Go is really capable. Go is fast. It's super fast. It's as fast as the say second-tier languages, like in performance speech, you usually have the first-tier languages are C and C++, basically, because they somehow are closest to the machine. And the second-tier languages are those with very fast compilers or just-in-time compilers, like might be Java and indeed Go. So these are very fast languages. For example, these days I do a lot of Python. I'm not a huge fan of Python, but I do data science things, and customers want Python, and as a freelance programmer I need to adapt. And Go is just like 100 times faster. If you do an algorithm in Python, you're basically lost. And in Go you can really do everything as if it was C or C++. It's really fast. So this is some praise. Finally, a last point. Then, of course, I'll show you the code where these elements come into play. The last point, threads. Go has built-in threads, basically, in the form of the so-called Go routines. You can launch as many threads as you want, and Go will intelligently map them on the number of hardware threads you say you want. So, for example, you can create 1 million threads. It's no problem. Go will then map them to the physical threads it have. This leads to very interesting patterns. For example, if you want to process files, you can code this in a very easy way. You just say process this file, and then you call this for each file you want to process. So if somebody calls this with 1 million files, if these were physical threads, like if you do in Java, he's the threading Java guy here, Davide. He has made presentations about this. You have a problem because you need to do some logic. You need to say, okay, I do 10 at a time, for example, then I join the threads to see if they are ready. If they're ready, I call another run methods on another 10 and so on. In Go, the language handles all this. You just think as if you have infinite threads on your hardware, and the language will deal with it. That's also quite nice, and I made use of this. This is, by the way, the Go command that gave the name to the language. You just say Go function, and this function will be called in a thread apart. Okay, so chess. Who among you know the rules of chess? Please raise your hands. Okay, so sort of the majority knows the rules of chess. Very good. So for those who don't know the rules, I will not show the rules. I will just quickly show you a board. So in chess, basically it's a two-player turn-based game where alternatingly each player makes a move, and you have different pieces, and all the pieces have different ways to move. For example, this is a pawn, moves 1. Pawns can also move 2. If it's the first move they do, then only 1. This is the knight. The knight can jump over things. This is the bishop. The bishop moves diagonally. Well, I need to take the black one, of course. Here we go. Let's move another knight. Let's move another knight. So here comes another bishop diagonally. And at some point, players start to take the other player's pieces. This is a take. I took here with the black bishop the white bishop, and in this case the white player will answer this with taking with the pawn, and this is interesting. The pawn has a diagonal move to take. It moves straight away, but it takes diagonally. So what's missing here is the rook. The rook is that piece over there. The rook moves in straight lines, any distance. So for example, this rook now moves 2 places. And finally we have the queen, which is the most powerful piece. The queen can move in any diagonal or straight directions, any length, like the bishop and the rook combined. So what's the goal of the game? The goal of the game is to kill this guy. This is the king, and this is the one you need to target. If you attack the king, for example, how can I attack here one of the kings? Let's see, I take a little bit help from the black player. So the knight moves here. Now, since the knight jumps in this L shape, the white knight is attacking the black king. At this point, the king needs to move out of this attack. It's called a check. So, for example, it might move here. And the rule is, once you get to the point where you attack the king and the king has no escape route, then you win the game. So basically, this was chess explained in 1 minute or 2. And basically, that's it. You think, well, it's a simple thing. Okay, Patrick.
Just a question. Do you also map advanced moves like rochade?
No, well, there are basically 2 advanced moves. I tried to pull under the rug, but Patrick exposed me. Basically, there are 2 special moves here. One move that you can do once in a game is a rochade. In English, it's called castling, exactly. You move the king 2. Normally, the king can just move one way in all the directions, and when you castle, you move it 2 steps versus the rook, and the rook jumps over the king. You can do this once in the game. You can only do it if you never moved the king and the rook before, and if the squares between the squares that the king touches are not attacked. So there's this extra move. This is once in a game. It's called castling because basically you protect the king. You put it in a castle. And the other special move that a lot of players don't even know is this one. Now I need to somehow see if I can do this. If a pawn advances here, okay, need one more move like this. Now, okay, now the king has to move out of check, of course. I accidentally mated the king. Now, so yeah, let's move another one here. Let me see. So what do I want to do? Okay, I want to move this one. Okay, now I have to move another bogus move from white, so I have to move this one. The other special move is the pawn can, as a first move, jump 2 squares. Okay, then only 1 from that point on. And if the pawn moves 2 squares, like I do here with this one, there's the special move that the black pawn can take it en passant. Okay, that it takes it to the square that was jumped over by the pawn, and this is called en passant. And there's actually a kind of funny anecdote about this. There's a big commercial chess playing website, which will be not named, because today we will make a little bit of ad for the open source one and not the commercial one. And apparently the commercial one had a problem that a lot of support action, it's a payment side, so you get support, commercial support, is that they got complaints about mysteriously vanishing pawns. And this is basically the en passant move that many players don't even know. So they got, my pawn one vanished, strangely I moved 2 squares, but then the pawn suddenly vanished. So that must be a bug. No, it's not, it's the en passant move. Okay, this is really everything. No, okay, there's one special move I forgot. If a pawn reaches the other side, like this, it can promote. So this is the pawn, okay, now it's checked. This is the pawn at the end of the road, basically, since the pawn cannot move back. If it gets here, it can promote it. It can be one of the major pieces, a knight or a bishop or a rook or a queen. So for example, now very handily, if I get a queen, I already also put a check on the white king. So that's the last special move. So you got en passant, castling and promotions. These are the 3 special moves. Now it's really over. Patrick confirmed there's no more tricks and nothing here. Okay. Yeah, you probably made a support ticket to that one side.
You forgot the draw.
The draw, yeah. Well, of course, a draw is possible if people only have the kings left, then the game is a draw because they will not be able to attack each other, of course. And yeah.
You forgot.
No, checkmate I explained.
Stalemate, if you have like.
Yeah, okay. Yeah, basically there are draws if you don't have any material left, or stalemate if there's a situation where you cannot move anymore, but you're not under attack, then it's also a draw. Okay, but that's less a move, but more a rule of how you finish the game if there's no other possibility to finish it. Okay, so this was chess. Okay. Another point in chess that we are going to need is the ELO system. In chess you can rank the quality of your play by giving you a score. That score is called ELO. And ELO is not a strange acronym, but ELO is named after this guy, a Hungarian named Arpad Elo. That's why, for example, if on Reddit you spell ELO with capital letters, there will immediately be somebody who trashes you and explains to you that it's not spelled capitally because it's the surname of this guy here. So how does this work? Basically, this is a relative rating system. It does not give you an absolute score, but it gives you a score relative to other players. It's a logarithmic scale. If you have 100 ELO rating more than your adversary, you will win, I don't remember exactly, like 66% of the games will be won by you. So it's a logarithmic scale. If somebody has 1,000 ELOs more than you, he or she will absolutely win. Because that's 10 times the higher probability to win combined, so it will be impossible for you to win. What happens if you create a pool of players, for example, a website where people play against each other, will say, okay, I have 1 million people, I will give them an initial ELO rating, usually 1,500 or 1,000, something like that. And then they will start to play. There's the guy that always wins, he will raise. The guy that always loses will fall below. And at some point, you have a nice scoring, and you see the beginners have like maybe 700 ELO. The top players have more than 2,000. And you get this kind of system. An important point is, this is not necessarily portable from one pool of players to the other. So it's not absolute. For example, if you play on side A and side B, you might have a elo difference of a few hundred points because you're playing in different pools. It works only inside the same pool that it's accurate. And this is important because what follows now will often say, this guy had 2000 elos, etc. So you need a bit of an idea. Basically, this is a little bit the scale. Let's see if there's a FIDE list. Okay, so this is the English Wikipedia. They have the English or the American system. Basically, if you are 2800, you're the world champion. If you're 2500, you are a grandmaster. If you're 2000, you're a very good club player, very, very good. You will beat everybody at your club. If you're 1500, you are a medium club player. If you are like 1200, maybe you're a beginner club player. A club player, nowadays a club player, of course, it can also be a dedicated online player. We are not, all of us are not playing anymore in clubs. If you are 800 or 700, you're a beginner basically. If you are down there, it's probably one of your first games, something like that. So this gives you an idea of this range. Again, between one pool and the other, there might be a few hundred elo difference, so don't panic if you don't know if you have 800 and I now offended you. It might be that you are on a very hard pool where 800 is not so bad. Okay, so that's the elo system. Now let's talk a little bit about chess engine. I explained these rules to you, and of course what people started to do obviously is I teach a computer how to do this, and the computer will be very good, and the computer can compute everything, and yeah, it's very easy. Huh? Okay, so the problem is with every move you have some possibilities. On average, you have like something like 30 different moves you can do. Sometimes you have only 20. If you need to escape a check, you have only 1 or 2 maybe. And from the initial position, you have 816 plus the knight's 18 moves, if I'm not mistaken. Yeah, okay, something like that. Later on in middle game, maybe 30, etc. So what happens? If I make a move, for example, black now says, what can I do? I can move the knight here, or I can move the rook here. There are 30 possibilities. Then white answers with another 30 possibilities, maybe like I do this. We have 30 times 30 is 900. Okay, so let's say 1000 to round it up. If there's another move and counter move, you have 1000 times 1000, a million possibilities. So if it's move, 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 there's a million possibilities already. And this, of course, explodes. Clever players will see, well, okay, I try to move the knight from this square over to that other square, right? I need to make a few jumps. I have to take care of this one, etc. And we will be maybe 5 half moves or 6, 7 half moves deep, and then of course this tree of possible move explodes, and a computer can easily maybe evaluate 1 million positions per second, but the exponential function trumps hardware here. So algorithms always beat hardware, I used to say. And you cannot challenge a very good player. So, for example, in the 90s, we still had the situation that computers were already quite fast. We did a lot of things with computer, but they could not yet beat a human. So here's a little bit the history of this whole thing. The very first chess program ever was written by none the less as Alan Turing, the famous pioneer of computer science, on paper. he had no computer to play it. He played it on paper. He wrote the program, and then he solved the program with pencil and paper because he had no computer that could do it. And this is the very first program, Tour Jump. People nowadays re-implemented it, of course, so you can play against the Tour Jump. And it was playing already nicely and could be the beginner, but certainly not a player who can play. Then in the 80s, people started to use the computers that were powerful at the day. There's Cray Blitz. Cray was a line of supercomputers at the time. Nowadays they would be ridiculous. I mean, like our phones are 1,000 times faster than these Crays from the 80s. No joke, this is not a joke, this is really the case. And the Cray had a very well-known program, Cray Blitz, which reached approximately 2000 ELO. I mean, it's always very difficult to calibrate this, and you have this problem, different pools and blah blah. But we are there. So it could play like a very good club player, but not a grandmaster, of course, and certainly not the world champion. Now, even people who don't know anything about chess and chess computers probably know the name Garry Kasparov and Deep Blue, because this is kind of a very well-known situation then. This was IBM who decided for marketing reasons to build a computer that could beat the then world champion Garry Kasparov. And they did so. They did it in 2 takes. I think the first match was 6 games in 96, where Kasparov beat the computer, and then they improved it. They spent millions of dollars to build it. And in 97, they kind of surprisingly beat Kasparov. This was a hardware feat more than an algorithmic feat, because they never published anything. Nobody knows how it worked. But they apparently they built ASICs, so logic chips that do nothing than evaluate port positions, and just made it very fast. They say Deep Blue could evaluate 200 million positions per second, which is faster than our modern computers with our modern chess programs do it. So they really threw hardware against the problem and did nothing algorithmically smart. So it's just a way to you calculate all these 3, very as distant as you can get. You evaluate the position. A very easy evaluation is just count the material, attach scores to your pieces. So a queen is powerful, it gets a lot of points. A pawn is not so powerful, get a few points. You count the material, you have an evaluation. Then you look 10 moves in the future and see how is the evaluation now, and you find the best move for your turn to play. Okay, so they did this. In the zeros, or in the years 2000, I don't know how to call this, many commercial engines came out. This was getting to start popular. People had PCs in their homes. Well, I'm talking as if it was the old Roman Empire. It's just 20 years ago. So people started to use their PCs to play chess against their PCs. Some of you might know these classic programs like Fritz, for example. Fritz is a German program who played chess in, like, it was good 20 years ago. Okay, so what happens is that, of course, computing power improved, but most of all, programming improved. People started to do very clever tricks to code a program that evaluates these trees as fast as possible, because one idea is to prune, so to cut bad moves early so that you don't have to follow. I mean, if I misplace my queen and lose my queen, then I don't need to further evaluate this branch of the tree, because now I'm lost. I lost a very powerful piece. So these were algorithmic advancement. These machines could evaluate way less positions, maybe 100,000 positions per second, but still they started to be stronger than the 1997 Deep Blue, and they reached the world champion level. There's a famous Kramnik versus Fritz. Kramnik was the world champion at the time in the, I don't know when exactly, in the years 2000, and there was this famous game, Kramnik versus Fritz, that I don't even know how it went, but in the end Fritz reached that level that it could beat Kramnik. So you could beat the world champion on a normal PC. Okay, fast forward 2008, there comes this strange program called Stockfish. That is a program that initially was started by a Norwegian guy, and then an Italian guy forked it and called it Stockfish because, according to him, this is the only product he knew from Norway. So he associated Stockfish, the food, with Norway. So he called his fork Stockfish because it was some Norwegian stuff. And Stockfish evolved. It was a GPL program. People started to contribute, and it evolved, and it started to be the best chess program. So in 2016, it started to win everything. Of course, there are championships also for a program. There's not one specific championship. There are different matchmaking entities. For example, here we have TCEC, which is a famous one. TCEC, you see here, has seasons. These are not years, they are shorter. Basically, they do a few months of games, and then they start with a new season afterwards. You see here they go usually a few months. And starting from 2018, you see Stockfish, 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 Stockfish. So this was a nice feat. You have basically free open source software that is the most powerful chess engine in the world. Okay, then, well, what happened? It happened that as in all other spheres of computer science, people started to think, well, yeah, why not do deep learning things? Machine learning with deep neural networks. They put it everywhere, so they put it also on chess. And nonetheless, then DeepMind, which is the company you certainly know, it's in the meantime it's bought by Google. It's a company where the founder recently won the Nobel Prize in chemistry for another feat he did with deep learning techniques in chemistry. And they made a program called AlphaZero, which uses reinforcement learning, which is a deep learning technique that can be applied to turn-based games. Any turn-based game with 100% information, basically. So not only chess, but also, for example, Go or Shogi or all these board games. And they did something really surprising. I mean, you have this Stockfish thing that for years is developed by hundreds of people that wins everything. And then they came here and had this neural network that could self-learn in 4 hours to play chess in a way to beat Stockfish. This was, of course, kind of a shock, because people then said, okay, then we throw away everything and give up. Some people also got very counter-aggressive to say. They said, well, yeah, that was a supercomputer by Google, and Stockfish runs on a PC, so it's unfair. But in the end, it turned out that DeepMind was right, and this is really a complete game changer. AlphaZero was not released, so they did another Deep Blue move. They made this very nice machine and did not release the code. People hated this, of course, and a community formed that picked up DeepMind's paper. They made a scientific paper about what they did without giving the code. The community read this paper and created Lila Chess 0, LC0. This is basically the same strategy. We create this self-learning thing, Lila Chess 0. They did not have Google's compute power, so this was done on distributed donated GPU cycles. So all the community members with their fast GPU contributed some computing power. LC0 was trained, improved, and then there was the Big Bang. In 2019 it won TCEC. Okay, so basically DeepMind was vindicated. They were right in the end. This thing works, and yeah, now you have Chess 0. If you go here again to the TCEC website, okay, here we go. You see at this point Stockfish here, the first season was season 15 in 2019, LC0 won. Okay, this was really a big thing, really big thing. People started to compare the engines. It's also quite nice how LC0 plays. It was really, I remember I followed chess already then, and it was really a big event. Now, the Stockfish developers are smart people. They did something, according to me, quite insane. They said, okay, we don't give up our beautiful implemented search. We don't give that up. We believe in that, and it's so clever, we keep that. But we will use a neural network for the evaluation of the position. So they combined the traditional search algorithm, tree search algorithm, with a neural network for the evaluation. How good is this position? Now, if you ever did something with neural networks, you immediately say this is a very bad idea, because the handcrafted bit fumbling C++ implementation of Stockfish could maybe on a nowadays computer could do like tenths of millions of evaluations per second. And if you ever run something through a neural network, you know they are kind of slow. For one signal to propagate, you, even if it's a small one like this, you maybe need to wait 100 milliseconds or something. So how can this possibly work? You get a evaluation function that is million times slower. And the winning idea came from Japan, from the shogi guys. Shogi is a board game that is popular in Japan, in some kind similar to chess. And they did an insane trick called NNUE, which is pronounced Network Neural Updatable Efficiently. And if you read this, you think, wait a second, this is mirrored, turned around. And indeed, you can also call it like this. And then it becomes efficiently updatable neural network. So this is, of course, a mega inside joke. The idea is that if you propagate, if you say I have a neural network with the input is a chess position and the output is an evaluation, you propagate the signal and you fix all the weights and you get your evaluation. If you try another move, you just move one piece. And so instead of recalculating all the weights, they recalculate just the path through the neural network that was changed by the different move. So it gets fast. Instead of like on a certain computer 10 million per second, they could still evaluate like 5 million positions per second. So it's incredibly fast. It's really insane. And yeah, this wins everything. So I find this very nice. The combination of a very antique tree search with pruning combined with the neural network somehow is the best thing. It's a kind of beautiful happy end. Huh? You combine machine learning with classical computing. And if you go again to the TCEC website, what happens there is that at some point you have Lila Chess 0, then they alternate. You see Stockfish, LC0, Stockfish, LC0, and then it's again Stockfish. And now it's again the domain of Stockfish, and Stockfish is basically unbeatable by anything thing of any kind now. We even don't know what the ELO is because we can't calibrate it. It can't be calibrated. They estimate it over 3,600, but it's a kind of meaningless number because you have other engines that are up there, but you have basically a pool of very good engines that are alone, and so you don't know. They might be 4,000. We don't know. We can't match them with the rest of the players. So Stockfish is GPL, LC0 CPL. So we are now in a situation where the first and second best chess engine are both GPL software. This is a big win for open source. Okay, so this was a little bit about Go, a little bit about chess, a little bit about the history of chess engine. Now let's go into my humble program, which of course is absolutely nowhere as smart as all these things. As I said, I liked Go and said, yeah, well, let's do a toy project. Let's program a chess engine. Something that I came up on the toilet in one morning. And so I'm going to show you the evolution. So what I tried, what were the challenges, how I choose to solve them. So let's start with part one, the idea. This is always blocked on my blog. Okay, so I want to have a toy project. As I'm working as a programmer, I know that you can't start to code something that plays chess. You need first to get a little bit the surroundings right. So first of all, how do I get a chess position into my program? For example, if I want to test something, I have my chess program here that I never find. Here we go. For example, I want to see how my program would do in this position. I need, of course, something graphical to move the pieces around and then input that position into the game. So this is the first standard people use. It's called FEN, F-E-N. It's a standard. There's somewhere a link here. FEN is basically a short string that encodes a chess position. Okay, so this is boring. Maybe somebody, a kid at home, starts to program immediately the moves, etc. I, as a programmer, know that the boring things can't be postponed. So this is one of the first things I did. I programmed a parser to get this into my internal board state. Everybody uses this, so if you have any chess program like this one, you can just do here some command copy, current position copy to clipboard, and then you get a little text file with this FEN encoding of the position. So this is universally used by everybody. So we need FEN. Okay. What else do we need? Where's my browser? We need second point we need, a board representation. So I need to remember, have a representation as some struct with the pieces, and I have to input output this with FEN. Then we need an evaluation function that says the position is scoring more for black, more for white. This usually is a number where a positive score is advantage for white and a negative score advantage for black. It's just a matter of agreeing. In fact, there's a protocol that turns it around. Okay, I can just count material. This is the first thing. And this also, if you learn to play chess, they tell you consider that a queen is worth 9, a rook is worth 5, a bishop is worth 3. And this is something kids are taught if they learn chess. So don't trade your queen against the knight, because the queen is much more valuable. So I may do this. A move generator. This is the single point here that was the most hard part. I need to have a board representation and come up with a code that gives me all possible moves from this position. It sounds easy, right? I showed you all the moves. You say, okay, I have a pawn, there's there's nothing ahead of it, so I move it one. I have one move. The knight has these L jumps, everything is good. This was an error and took most of the code here. Then I have to do a tree search. Here I throw around this alpha beta thing. In the end I did not even use it. I need to search some kind of trees of possibility to find all the evaluations at the leaf nodes. Okay. Then I knew immediately that I don't want to do graphical programming. I hate application programming. I never do that. I'm more of a backend guy, so I certainly don't want to move sprites around. Let's do that for other programs. I looked a bit into this field, and what I found out is that basically all chess programs have a clear separation between a GUI that does everything and an engine that just calculates. And there is a very famous protocol which is called UCI that connects the two. We will see this immediately in action. It's a very simple text-based protocol where, for example, I say position, start, pause, go. It has nothing to do with the Go language. The command is go. And then the engine will compute. This works for all the engines, doesn't matter. So UCI is also an universal protocol. For example, I can show you, well, I will show you with Mochi because Mochi is very lenient and will accept everything. We have Mochi. I'll do Mochi minus V. Okay, here we go. I do position. Now I'm coding UCI by hand. Of course, this is done by the program then. Position, start, pause, go. We'll compute and come up with a move. Okay, I move G1, F3. These are the squares on the board. So if I start from here, you can see G1, F3 would be the knight that jumps out here. So basically this is UCI. Now, with UCI, I have the possibility to have the engine talk to any chess GUI. So I solved the GUI problem by implementing a protocol. This is a very programmer-like way to think. If you don't have experience, you maybe start to do some GUI and so on. But this is actually not the main problem here, and so I offloaded it to somebody else. I want to keep it short. Probably this should be a few thousand lines of code. I managed to do that. The code is now 2,000 lines, which is very good because there are tests and debug prints and all kind of stuff. You probably could reduce it to 1,000 lines of code. So it's very compact. And this is also my idea. And I want to use it on this website, Lichess, we will talk a little bit more about soon. Okay, I did not have a name yet. And I decided to publish it on Codeberg, not on GitHub, because I like Codeberg more. Codeberg is for people who don't know this. Codeberg is a Git repository. No, it's a Git repository website, which is free and open source, and it's run by a German eingetragener Verein. So you're kind of more better hosted here than on the famous GitHub website. Okay, let's move back. So this was the idea. Now, first part, board state and fan input. First thing, of course, first things first, important things first, I got the name. The name is Mochi. Mochi stands for Minor Chess Engine, like this. So this is the name. I don't know if I have a logo here yet. No, the logo is not done at this point. So Mochi is also a Japanese suite. So there's also an idea about these usual acronyms that have double meanings and so on. Okay, here we go. This is the board state. Here I have a debug output. What I just did here actually also gives a debug output that you don't see in the UCI protocol, but it's logged to disk if you want to. And this I can show in another terminal. Now comes the part where Chris opens too many terminals. And here you see the debug output of what we just did. So you see in Uchi, you just introduce yourself, and then you wait for user input. In the debug log, you see how this works. You see here this Uchi in. This is the input that comes via the Uchi protocol. This is the position start port I gave. And then in the log output, I will immediately dump my board state. I use here the same notation that also Stockfish uses for its log, which is uppercase letters for white and lowercase letters for black. So you see here rook, knight, bishop, queen, king. Knight is written with a K, but to not have the ambiguity, they write it as an N. Okay, so this is a board state here. I have to remember, did I already do the castling? I have to remember, is an en passant move possible? So there's some kind of details I need to remember. So castle rights here. This is encoded here. White queen side. That means white can castle versus left. Or white king side. White can castle versus right. There are two rooks, so you can castle left or right. And of course, if the rook moved, I can't castle anymore. So this flag goes away, and it's all remembered in the board state. Okay, so now comes an Uchi command in go. And my code now uses the move generator to get all possible moves. I don't know, these are 18, right? No, there are more. Okay, I made a mistake. There are more. 8 plus 8 plus, I don't know. Anyway, this will be correct. So you have all these moves. This is always the squares. You see B1, A3. This is what is this? This is the left white knight that jumps out. B2, B4. This is the pawn that moves to ahead, and so on. Okay, it will evaluate this tree. You see, it's already using more than one thread, and it will come up with this evaluation at the end. Now you might ask, why is this already different from 0? There were no takes, etc. Remember that my search is limited. I look a few moves ahead, and these are the best evaluations or the worst evaluations I get. There are already captures here, possible captures, and there is a horizon effect. It's called the horizon effect. As I don't see infinitely deep, maybe I stop. There is a capture, I stop there, and now I think it's an advantage for white or an advantage for black, because there was a capture, and I don't realize there is the gegen capture. How do you say that? The capture that takes it back. So I'm always kind of wrong. Otherwise, it would be 0 in a more in a hypothetically infinite engine. It would be maybe 0, or we don't know. Maybe if you solve chess, you find out that white always wins. I don't know. Nobody knows. It's not mathematically known. Okay, so I get this. I have the move generator. I have fan input and output. I can do a lot of things now already, I thought. And now the problem is my move generator correct? Do I, in all cases, find all possible moves? I need to pay attention. Am I in check? Is castling possible? Is there an en passant? Is something blocking? It's not so easy. I researched this a little bit, and also here I found out there is people who do stuff, and it's called PERFT, for performance testing. It's kind of a word that in the chess engine community people use. And what they did is they come up with reference positions. Okay, let's open the code at the end. Otherwise, it's always very sad. Here I'm using Goland. Okay, this is incredibly small. I don't see anything here. Okay, so for example, here we have some trial position. There should be, I can't even zoom this. There's a a website here. Yeah, it is. Okay, yeah. There's a website here. The chess programming org is some kind of wiki where the community stores some results. Okay, and in this page they have birth results for difficult positions. So they have, of course, the starting position. And what are these birth results? Basically, it says if you compute the move tree at that depth, you end up with so many moves. Okay, not 18, but 20. 20 because the knights can jump out. It's 8 plus 8 is 16, and the knights can jump like this and like this. So 4 knight jumps, 20. 20 is the number. So basically, if you take the starting position, you go 1 half move deep, you end up with 20. 20 is the number. If your engine also outputs 20 moves, it's correct. If it outputs 18, it forgot 2 possible knight moves. Okay, so I included these positions here. Position 2, position 3, these are all recorded positions that are hard. They give you the fan of the position, and then they give you the result. They not only give you how many moves you have at that certain, but they give you also how many captures you have, how many checks you have, and so on. You can use to test your move generator. I did this, and I was happy because everything was perfectly right. I checked 19 billion positions and said, wow, if it computes correctly 19 billion positions, everything is correct. But unfortunately, check is more like bookkeeping and less like science, where you say, well, yeah, it's 3 significant digits is already a lot. So what happened is that I was just not sleeping well and said, now I need to go deeper, and left it run a bit more. I got to depth 8 for the starting position, and I got 84, what is this, 84 billion position, almost 85 billion positions, where the correct result is this one. So I got 416 more moves. So 416 over 85 billion moves. Now go to the debug this. And this took probably more time than the whole rest of the programming to debug this one. Where do I get these 416 moves? In the end, I got it after some furious debugging. At some point, I need to check if the king is in check, if it's attacked, because I can't do another move if the king is in check. And I said, well, the code that checks if the king is attacked considers all the opponent's pieces, but not the king, because the king cannot check. You can't check with the king because you expose your own king, so that's an invalid move, so I did not check that. But the move generator did not know that, so he gave check with the king. And this was my bug. I fixed it, and at this point I did not trust it. I went to depth 9, and also this difficult position I went a little bit over it, and in the end I have 2 trillion positions, and then I said, okay, now it's likely correct, and I hope it is. I never got more than that. I think with 2.5 trillion positions we can be sort of cool. I left this code in Mochi, so each time there is this is also a programmer move. Built this right into the code, so if you make a change you can just quickly run it again. It's the testing mentality. And indeed you can call Mochi with birthed. Then you can say a fan. You can give a fan string, and the string it will test from that position on. So for example, I could just use one of these chess programming wiki positions, and in this case I say I built in that I can say just chess programming wiki. So it knows I want to chess these special hard cases, and then I give a depth 4, for example, and it will output these numbers, and also a statistic with how many moves it generates per second. So this is nice because I've changed something. I can rerun it quickly and check these numbers again. It will give me green or red, so I'm quite sure. I never actually, since then, I never recently have it run again to this position because it takes a long time, of course. You see it does 7 millions per second, but you need to reach 2.5 trillion. So you need to have it running a little bit. Anyway, the logo. The really important thing is Mochi now has a logo, and this logo was drawn by my son, and it resembles the shape of this Japanese sweet, which has a crown because it's the king on a chessboard. Okay, so here we go. We have a move generator, we have a logo, we speak the Uchi protocol, so we can communicate with chess GUIs. We did it. Mochi plays chess. Here we go. Now I can plug it into my GUI. I can play against Mochi. I will show you with this GUI. It's not important which GUI this is. You can use, there are tens of different GUIs you can use. All of them can handle this. You go to the thing where you import the engines. In this case here I have a few engines. I use Stockfish, of course. Nobody beats Stockfish. Hierarchs, and humbly in the last position, Mochi. I will show you how this works. I remove it. I add it again. You just give it the executable. In this case here, I already opened the path. The executable. And it will already call it. It will identify itself. Here, this is too small to read. This is the -v, the version information, already there. And it's done. Now the chess GUI can use this engine. This works for every engine, so it's nice because it's really standardized. You can configure this. Uchi has also a way to set options. Mochi at this point has just one option. You can set how many threads you want to use. On this machine I can use a bit more. 4 is the default. I set it to 6 here and do OK. Now I have Mochi. What can I do with Mochi now? I can analyze the position. I can say, for example, if I play a little bit around here. Okay. So at this point I ask the GUI, please ask Mochi what Mochi would recommend as a move for black here. I just pick up something here, Analysis Explorer. I'm very bad at this. I have a mouse, then I'm better. Mochi, okay. So it will run Mochi, and here's the output of Mochi. Mochi will say, well, take the knight with the pawn. It says here, the e-pawn takes d4, which is correct. Because at this point, black says, yeah, thanks for the free knight. So you can use it to analyze things. Okay, you can play against it. Here this GUI allows to play against Mochi. For example, I want to be white from this position. Now I'm playing against Mochi. Okay, now, well, I lost already a knight, which is bad. Will do something. And Mochi will do this. So I move here. And Mochi will do that. So the GUI via Uchi streams commands, input, output, and I can play against Mochi. What should I do here? Take the knight maybe. Okay. As I switched on debugging here, we see all what is happening here now in the debug output. This is off normally, but it's of course very handy to have something like this, because if it makes a strange move, you can a little bit see why did it do that. Because it thought it was the best move, etc. There's some statistics here, how many nodes were checked. This is the total node, also the speed, how many nodes per second it evaluated, and so on. Okay, so this is great. Now the elephant in the room is how well does Mochi play? And this is the elephant in the room because it did not play very well here. I estimated it like 1000 elo, then I did an update. It's a bit hard. I played against it. I somehow used the GUI to have hierarchs play against it. It was not so clear. I thought maybe 1000, but then again, maybe it's only because it's blitzing, it's fast. If you think a little bit more, you beat it easily, so you think, well, it cannot be more than 1000. It's a bit tricky. I was not so sure. Maybe 1000, maybe 1200, something like that. At this point, a few things are missing. So I have no idea how good this plays. At this point, the depth was fixed. It was hard-coded. It always calculated the 3 to 5 positions ahead, not less, not more. Yeah, it's not very accessible because you need to download a binary, install a chess GUI, and nowadays people don't use so much the GUIs anymore. People play online. Okay, so what is the major platform where people play online? It's the famous commercial one that has a whole support group that explains en passant to people. And then there is this site. If you play chess, I absolutely recommend you go there and make an account here. This is a very nice site. It's a French onlus. How do you say onlus in English? Non-profit organization. Headed by a French programmer who made the most part of it. The server code is open source, so you could basically also run it on your own, but it's no sense because people want to have opponents, so you go to the original site leadchess.org. It's completely free, it's adless, it's supported by donations. They have, as they are non-profit, they have an open book. They need about 400,000 euros per year to run these whole things. You can compute how much a single game played here costs them. There's the computation, and you can donate. And absolutely recommended. If you're on this other website with the green theme, try to make an account here. This is really cool. It's really cool. You can play anonymously. I could click, for example, here now and play against another anonymous opponent, or I can sign in with my account and then I have my elo rating and I will be paired with somebody in a similar range and can play online. While this site is known for human players, humans play there, they also did something very interesting. I'm skipping a little bit ahead of the last part of this, so I will jump a little bit over here. I will also tell the start later. So what they did is they offer an API for bots. So the idea is, of course, not to have Stockfish there. They have Stockfish there on their own. If you want to play against a bot, of course, they have Stockfish. Everybody has Stockfish. It's more an offer to the community of engine programmers that can publish their bot there. How does this work? You don't upload the binary to them because it would need to run on their servers, and they say we don't cover the costs for your engine to compute. So they have an API, and there's a very nice open source project which is the Lichess bot bridge, which does Uchi for you. So basically you give it your engine and it will speak Uchi to your engine and the Lichess API versus Lichess. So basically it's a super deal. You need just to start this bridge. I did that and it was surprisingly easy. I can show you the server where this is running right now. Okay, SSH MochiBot. Here we go. And I just ran it on Screen. You might know Screen to run, you are using Screen all the time. because if I'm sharing a server with you, I see always 7 screen sessions from Davide. I can attach to this, and this is just the bot bridge that runs. I could, it's not playing right now, so I can stop it with Ctrl+C, relax it. I hope. Okay, it's exited, and that's it. Now the bot is not online. If I start it, Python Lichess bot by, it starts and it will publish my bot. It's as easy as that. There's a configuration file, of course, where you give the path to your executable, and where you can set things like, do you accept challenges to your bot? Do you want that your bot challenges other people? And you can do a bit of settings. You can say also, this is the minimum game time. There's a thing called time control, where you say, I need to do a game in 3 minutes, then it splits, or in 10 minutes, then it's called rapid, and so on. You can say, my bot is slow, I do also only at least 5 minutes, or something like that. It's a small configuration file, and that's it. Okay, I will exit screen here and leave it running. That's the one. Now, this made it possible to publish Mochi, and here it is. This is the screenshot. If you go to Lichess, you can of course use, well, I know the link by heart, but if you don't know the link by heart, you can go to my website. Okay, I did not say what my website is. It's 1006.org, and you can go to the blog, and you will find these entries I'm showing you all the time. And here is the link to the chess bot. So you can challenge this. It's online. You see the screen here says it's ready, it's online. If it's gray, the bot is not online. The information stays there. Lichess remembers that their bot is there. Of course, I made the account. This you need to do. Did not say it, but of course you need to have an account on Lichess. And then you pick, this is going to be a bot account. And then Lichess put this bot here, and you can use the bot bridge to run it. And here you challenge it. With this menu, you can challenge it, challenge to a game. You can do it anonymously. If I click here now, I start a game. Or you can log in and do it with your official name, with your official rating. Then you do a rated game, and the ELO will be calculated for you and for MochiBot, etc. Okay, so don't make the mistake thinking that Lichess is a site for bots. This is a side project for Lichess. Lichess is for people, for humans. This is just something else that they offer, and it's nice because you can play humans versus bot, or bot versus bot. There are a few rules. For example, humans can challenge bots, but bots can never challenge humans. Some rules. They keep them a little bit separated. They also have a nice big bot tag here, so that's clear. This is not something I did. This is something they do, so that it is perfectly clear. This is not a human player, because using engines as a human player is prohibited. They will ban your account if they spot you making stockfish moves. Okay, so this is something I think every chess engine should do, because it gives immediate access. Now let's play a game. Well, we'll do that at the end. Do not get ahead of what is still missing. Where is my dog? Is here. Where was I? Okay. For this dog, like a week ago, I started to get the Mochi again in my hands. I did a few improvements. I will not go into this. Now it's a bit faster, and there's also a fix in the Uchi protocol. I think it's nice. The most important thing is I also don't have a fix depth anymore, but now it is adaptive search depth. It always searches 4 half moves deep, and then if there's interesting things happening, it will search up to 6 moves, half moves deep, but not every move, because otherwise it would not be fast enough. And this is of course one of the major tricks. All the good engines do this in a very smart way. I do it in a stupid way, a very simple way. Basically, I say if I have my 4 half moves, I'm at the end at the leaf node. I will see, is there now, has there been right now checks or captures? If yes, I will continue. If no, I will stop there. If it's a quiet move, I'm not so interested. I will leave it at 4. If there's a check, it's going to be dangerous, so better calculate a little bit ahead. I think the improvement will come from here. I will probably need to make this a little bit more intelligent. So lead chess, we have lead chess, and finally the last version of Mochi before this update here had this problem that I don't know how good this plays. How can I improve it if I don't know? I mean, I can play against it and see, I made a bad move here. Then I change something in the evaluation to not make this bad move. But who knows if at this point Mochi makes other bad moves. You can't try it and code. It's not like a program that a GUI program that you can test by clicking and see, oh, there's a bug here, we'll fix it. Because you never kind of test the whole thing. So I was looking for a way to officially benchmark this. And what I found is this very interesting, again, tool that is QChess. QChess is a GUI, you can use it as a GUI, but it has a very nice tool that is QChess CLI for command line interpreter. And this allows engine-to-engine matches. You give it the path to your engines with some parameters, etc., and say, go make 100 games. Then it will call the engines alternating black and white, and it will compute a relative ELO. It will say, okay, engine B is 50 ELO better than A. This is perfect because you can pick an engine that has a setting to limit the strength and say play at 1500 ELO, test it, compare it, and it will be giving you the information, okay, this is Mochi sucks. But you can also do a very nice thing. You can say, okay, I make a possible improvement to Mochi. I have a new version. I play it against the older version. I play 1000 games. What will be the outcome? Is the new version 50 ELO better? Good. I will push the change. Is it bad? Okay, I will be a JIT, what is it? JIT restore or checkout. Checkout works, but there's a new command. I always mess up Git commands. This is the way Stockfish does it. If you submit a patch to Stockfish, they have a thing called Fishnet, which is donated computers, where all versions of Stockfish will play against each other. They will accept your patch if it comes out that improves ELO against older versions of Stockfish. So they go ahead like this. So with this thing I can do the same for Mochi. I did it now to answer the first question, how good this plays. Here is the call. I had it play against Stockfish 17. Luckily for me, Stockfish 16 did recalibrate. Stockfish has a feature where you can say, please play at a given ELO. And they just recalibrated it, so it's kind of correct. And I had it play against 1400. And it came out that Mochi is 1447. Plus minus this number. Then I had to play it against Stockfish at 1500, and the number agreed. Again 1400 something. Okay, so now I know Mochi is about there, 1400, which is quite bad for an engine. It's probably, as it's playing very fast, Blitz or even faster than Blitz, it would probably kind of be okay. A club player or an online player would have trouble if he or she is not 1400, but of course if you play longer, then the human can strategically go deeper and it will not be 1400. So take it as 1400 for fast time controls, certainly not long time controls. I also cross-checked this against some other programs and kind of they agree. here Lichess for me also does this automatically. If you publish your bot and say, yeah, I want it to challenge other bots, you can give some timings, etc. It will do it. And Lichess also calculated the ALO of my bot here, Mochi bot. I lost the URL already, and it came out at, look here. Okay, it actually for Blitz it just went below, a bit below 1,400. So we're there basically. Of course, this fluctuates a bit. The lines you see here will be, this is 1 point per day, but it's online just for 2 days, so it is basically not a curve yet, but it will convert versus the real value. So all agree it's 1,400. Now, okay, this is not very good. I mean, it's not bad. It plays fast. It's not bad, but it's not very good. What I want to do next step is to improve it to at least 1,600. I can do that thanks to QChess CLI, and then I will publish it as 1.0. Okay, so let's have a. I know everybody's looking to see a little bit of code. I will show you a few interesting parts. So basically we have here board, engine, perf I don't need, and yeah, that's it. Basically there's a logging, testing. Okay, so this is kind of everything. Let's start maybe with the types. Here, this is my board representation. Go has a thing that looks like a struct. It's like a C struct. This is all the information I need to put into the board. If you're familiar with other languages such as C, this is quite a standard thing. I do something very simple. I mean, professional engine people will scream in horror here. I use an 8x8 static array for my board. And I have just bytes there, and the bytes are basically the ASCII characters of the pieces. So the big R is the white rook and so on. Of course, professional engine makers use bit fields and do some bit fumbling to compress this to make it small and so on. I'm not interested in super optimized stuff. I want to keep things simple. And here you see I'm using, these are enums. Enums, basically, enums you do in Go, you can do an enum by using the const keyword and then use this special keyword iota. Iota here is 1, and it will automatically fill in 2, 3, 4, 5. It's basically an enum where you don't have to repeat the number. And for the rest, you see I use here all kind of ints. This is very interesting because when I said this version is now faster than the one from a year ago, one of the biggest speed up came because here I had a string. One data type was here a Go string, and there's some overhead with this because string is kind of a complex object, etc. And I removed this and put an uint with a bit field. This is the last move. This is now bit field. And this made it a lot faster. So don't do strings. If you want to do something very quickly, don't use strings in programming languages. Okay, have a look at the move generator. The move generator gets a board and then computes all the possible moves. As you can see, if I scroll a little bit about this thing, it's very simple. It takes this is a slice in Go. It's like an array, but it's variable length. In Go, you always mix up. For example, in C, you would put the array right to the type name. Here, you put it left to the type name. There are some kind in Go. You do like SQL. You say not int x, but x int. Maybe I like SQL. Maybe that's why I also find Go nice. And this is very easy. I go through the ranks and the files, 8 by 8, and I have my candidate boards. And if I find a piece, if I find a pawn, I know, okay, the pawn can move. is the space ahead of the pawn free? Fine, so I can move one square, and then I generate a new candidate board where this pawn has moved. It's a copy where the pawn has moved, and add it to the candidate board array. I do this for all possible pieces in all possible moves, and at the end of this function I will get a list of candidate boards. Then I do some more processing here, and at the end I return the candidate boards. As you can see, very easy. If you look at Stockfish, you don't understand anything because they use assembly intrinsics to manipulate bits. It's really crazy. Whereas this is really quite readable. It's of course a bit messy because you have a lot of pieces, etc. But it's quite something that you can code probably in any language without too much difficulty. One but last thing, the evaluation. The evaluation is also, again, very simple. I count material. Here is a switch case about all these pieces. As you can see, I use just the ASCII byte to encode the beast. This is a knight. It's a white knight. Okay, so I say I do very few things here. I see if the knight is at the border, it counts a bit less because you know that knight should not be on the border. On the border they are a bit trapped. They like to be in the center where they can jump in a lot of places. So I say if you're on the border, I give you a knight on rim score, otherwise you get a knight score. And here I have all these constants. And you can see the knight is 300 and the knight on the rim is 250. Tuning these things is completely not done yet. I should probably do that. Find the right weights to do this a little bit better. So basically it's just a very simple evaluation. Again, this code is just what is it, 400 lines, not even 400 lines. Okay. Finally, compute. Okay, there's protocol with the UCI communication, that is just parsing some text. And then there's compute, which calculates the tree. And that's even smaller. That's a total of 200 lines. Okay, and that's the whole of Mochi. You don't need more than this to do everything. And here we see one interesting thing. There's the function called Go. This is not Go because it's the Go programming language. It's Go because the UCI command is Go. So yeah. What I do here is I compute the possible moves here. Get valid moves. Here it is. Okay. And now look. This is the nice thing in Go. I call walk, which recursively calls the tree from all these boards, but I put this strange keyword here, go. This is the go keyword to say do this in a coroutine, do this in one of these virtual threads. Don't care. If you run this, it will not wait for walk to exit. It will just loop over the first nodes and call 20 go routines. How are they mapped to hardware? I don't care. I just say to go with this command here, set max cores. I say go, please use at most so much cores. I don't need to do this. Is automatically set to the number of cores I have if I don't do this. But I want to do this because I want to have the option to set the threads. I want to do this. So I do it. And then everything is handled. Now, is there a join? No. Normally in thread programming you need to join threads and do some load. No, you don't have to do anything. You give a channel. You see here's a worker channel. Channel is a special data type in Go. You give it, I pass a channel to this function, and the function will communicate via this channel with my main program. I can write into the channel with a major sign and read from the channel with a minor sign. Here I'm reading the output here. This is the minus sign. I'm reading the output from the worker channel. So if a thread finishes, it will write something there, and in this loop I get it out of this channel. It will communicate back the results for its tree search. It will communicate the results back. I will do some kind of logic here, and finally output the best move here. It will find which one is best and then output it. That's it. So multi-threaded programming is very, very easy. This is one of the nicest thing in Go. And that's basically this is the walk function. The walk function is a tree. This is all a little bit more complicated because there are some things I need to check. For example, here if I see a checkmate, I will give a huge evaluation because that's obviously the thing I will reach. There is a recursive call here somewhere. Here it is. Walk calls walk itself. There is a termination condition, as must be in all recursive call. When I reach a certain depth, I will return. Okay, as you can see, a nice simple language with super cool features, very readable. It almost reads like Python, I would say, but it's really as fast as modern just-in-time compiled languages or compiled languages. Okay, now I know I should finish at 8. We can quickly make a game against Mochi. Let's do that quickly. Of course, by now you know my website, so you can find the links to the bot, to do the code and everything, the repository. So please, where's Stefano? Stefano, you promised me you give me a star because I have just one. I have just one star, so please give me at least a second one. Last time you promised. Okay, so let's play against this. We could use, let's use, if the Lichess bot is available, we can use the Lichess bot, otherwise we can run it locally. It looks like it's available. Let's make an anonymous game so we don't lose rating if we lose. Challenge to a game. Okay, so this is automatically unrated now because I'm anonymous. Otherwise there's a box more that asks me, do you want to do unrated or rated? That's all good. I need to give a time because Mochi does not accept, has a range of times. So let's maybe do 5 minutes. That should be something we can manage with a small increment. For each move you get a small increment. You want to play white or black? Let's click here. If you click here, it picks a side randomly. Okay. So if this waits, it might be that Mochi is busy in another game. I hope not. If it is busy right now in another game, we will just play locally. No problem. Okay, this looks like it's busy in another game. I will check it out. Okay, Mochi, where's the Mochi bot here? Okay, no, it is not playing in another game. Then it should actually answer my challenge. Don't know why it does not answer my challenge. It's not in another game here, otherwise you would see here a red mark saying that it's in another game. It played it played 2 minutes ago. It lost against the bot called Hard Rock.
Now he's depressed.
Sorry, pardon me?
It's depressed.
It's depressed because it lost against Hard Rock. I don't know. Let's see if maybe it's not accepting anonymous challenges. I don't know. Let's connect to the MochiBot server. Let's do a screen -X here. Next challenge we created. Now this is his challenge, but it did not get my challenge here. So it did not see this. Maybe it's Maybe it's not possible to challenge it anonymously. I'd never tried, of course, but I thought it was possible. Let's sign in with my account. This is not Mochi's account, this is my personal account. Okay, and challenge it from here. So, challenge to a game. As I said, now I have the possibility to decide if it's rated or not. Let's do real time. Minutes 5:3, and I want to do rated, and again okay, now it works. Okay, maybe I have in the configuration file that it does not accept anonymous challenges, I don't know. Okay, so please suggest moves. We are black, Mochi is white. As you can see, it's Mochi's quick. I thought if it's playing bad, at least make it quick. It's stupid if it thinks 1 minute and then makes a stupid move, right? But that's thanks to Go. Go is really fast. Okay, what should we do, guys? Who plays well here? We must win this. Take?
Yeah.
Okay. We must win this. We must win this. Okay, let's move the bishop. I want to castle to the left. So, yeah, Mochi always pushes these pawns. It's maybe not a so good strategy. Let's block this a little bit. Otherwise I have all this. This is kind of not a good move because it does not develop. It's just pushing randomly pawns. So already not playing well. Of course, now I say not playing well, then I will lose. Okay, let's castle. So we moved the bishop here. We can castle now. Castle is important. Mochi should castle too, but it does not. So I should increment this castle bonus, one of these constants we saw. Okay, now think, because we don't want to fall into some trap here. Let's move the knight out. No.
Will be eaten.
Sorry?
Will be eaten if you move.
They can, yeah, but we can take back. That's not a problem.
Okay.
We can take back with the bishop,
Yes,
right?
Yes.
So let's see what it does now. Okay, it's the usual pawn pushing, which is probably not so good. Let's take ourselves. Now it should take back with a pawn. Yeah, this is expected. I need to move this knight out of the way. Let's do a quiet move. Let's move it back. Because I know I have to trick it positionally, because tactically it's better than me. Somebody has a good move in mind. We can attack the rook over there, right? Attacking this rook. Don't know if it makes sense, but okay, yeah, it castled out of the way. But now I see a weakness here, because this is quite open here. The king is not well protected, so we should try to enter here. Let's do something brutal. Let's sack a bishop. Let's sack a bishop and then move the queen over there and see if we can kind of trick it. Now I have the bishop that is pointing towards the king, and the king is completely unprotected. Okay, very smart. Very smart. It's cutting off the bishop. Okay. Yeah. Let's do something. I need to pay attention to not fall into some counterattacks. Let's see what happens here. Mochi can take en passant if it wants, or it can take with... okay, yeah, I did not see this. Okay, I did not see this. This is bad because I'm losing now also this... I'm losing 2 pawns now. This is really bad. I should have seen this. This is not good. This was a bad move by me. Losing this pawn here was kind of catastrophic. Okay, yeah, my bishop is blocked. I think I did not... I didn't do good here. I think I'm sort of lost already. Somebody has an idea. Let's attack the bishop here. I will cut this out of the YouTube video. If I lose, Well, on the other side, if I lose, at least I lose against my program. Okay, so this is brutal. This is completely brutal. No, because if I take the bishop, I lose the rook. You see this here? I lose my rook if I take the bishop. Really bad. I need to take the bishop first, give check, and again now I should not take the bishop because I get the queen here. I should maybe first do this. I'm in a really bad situation. I mean, Mochi is exposed, but I'm exposed too. Okay, so what should we do here? Let's this bishop is really dangerous. Let's attack it like this. Isn't there a better player here? I mean,
Why don't attack with the queen?
what should I attack?
The king.
Yeah, give check, but I can't mate it with the queen alone. I need to coordinate my pieces. If I give check here, it will just move the queen over there and I don't win anything. I need to maybe... Okay, I could move the rook here, but this is very dangerous because I tend to trap my king like this, right? Maybe better to move this away so the king has a bit of luft. Okay, now I can move the rook here. Now my knight is trapped.
You can take the queen.
Yeah, but then he takes back with the pawn.
Yeah.
And I'm kind of not in a good... This? No?
The queen.
I take... Oh, my queen is under attack. Right. Okay, then give check. Maybe give check. Give check. And now this... I want to... This is a pin. The queen is pinning here my knight. I can't move with the knight away. So I want to move out of the pin. Should I do this? Can I do this?
Okay.
Of course you can.
Yeah. Of course I can lose, right? Yeah. I lost. This is so embarrassing. Yes. I did not see that the bishop was protecting the... And this was a mate in one I did not see. I play really bad. Well, at least Mochi plays a little bit better than my bad play. Okay. So, yeah. Let's open the question round at this point. Somebody said challenge again. Yeah, well, we can always do this later. But now it's time for where do I have this discussion slide? Stefano intimidated me to open the right slide. Well, let's close everything. Okay, this I need to pay attention because I need to keep screen open. Okay, this was just a local log. This we don't need anymore. Delete. Okay, so this slide is basically the out. You want to take the word again? Now it's discussion time. So if there are questions or comments or praises, it's a kind of win-win. I can say Mochi plays well or I play well. It's a kind of, you can always see it in a positive way. Please.
Somebody has questions or...
First on this, did you play against Mochi sometimes? And how good are you in general against Mochi?
Well, not very good. I think the point is, if I play with Mochi speed, I lose always. No way, I lose always. If I consciously say, okay, Mochi, you move in 1 second. No, I think 10 seconds, checking everything. Then I think I can win. Okay, now I just lost. But if I really pay attention and don't move quickly, but really look at every piece, etc., I think I can win. So I'm playing in a club here also in South Tyrol, and with this FIDE now has changed the rating, but with the old rating I would be 1280. So like 100 elo lower than Mochi. And in Blitz this is probably correct. In Blitz I would lose 6 games out of 7 or something like this. But in longer time controls, Mochi has no notion of time. It does not take advantage to compute deeper. It will always move in 1 second or about 1 second, as you saw, less than a second here. And then I think I can beat it, because in a long time control it would probably play like 1,000. Mochi would play like 1,000, and so I could beat it. This is one thing I need to do. I need to do adaptive that, of course, Uchi gives you the time on your clock, and I have to make it adaptive so that the depth increases if Mochi sees that it has more time. Then it will be 1400 also for long time control, because it will naturally think longer if it has more time. And then I probably will have a hard time beating it in any way. But I'm also quite bad at chess, so don't take me as a standard.
I have a question on using Go. Is there, so 2 questions. Is there any work for me to do if I want to use hyperthreads? And second question would be, is there already built in the syncing options or syncing logic for multi-threads? Or do I have to use some libraries to actually sync or make critical sections, etc., needed for parallel programming?
Okay, so Mochi has these Go routines. The technical term is co-routine, and they call them Go routine as a play on word. And these are to be synchronized with channels. That is the native way to do it in Mochi. So you should communicate via these channels. So the program that says Go function should have a global channel or parser channel or somehow, and then all the threads should talk to this channel. You can do logs and synchronization and classical things, but it's there, it's built into language even, but you should not. It's not the Go way to do things. The Go way would be to do it all with messages.
Okay.
Yeah. About hyperthreads, hyperthread are this Intel thing where you have the double number of threads. This is actually a bit of a problem, because Go on x86 chips sets the maximum parallelly running coroutines to the number of logical cores as reported by the operating system, and that is double your physical cores. Some computations must or maybe not optimal. It's a little bit unknown problem also in traditional threads, that sometimes it's fast if you give the real number of cores. But you can set this in here. I quickly showed it before. You can set it with this command here. Zoom it. This one. Runtime is an object in the standard library, and you say Go max box and set it to some number. So for example, if you have an Intel core with 8 physical cores, 16 logical, you might want to set it to 8 instead of the default 16 to optimize this a little bit.
Okay, thank you very much.
Someone else?
Maybe yeah, first very interesting. This a question. Do you know if artificial intelligence can write something like this, or
okay. You want to tell to some LLM, write me a chess engine.
Right, not to play, but to write the code. What do you think about this?
Okay, this is 2000 lines. If you take out the tests, the debug log, etc., you can condense it to 1000 lines. I think 1000 lines is still a little bit out of scope of LLMs, but we are getting there. I see now people post, I made a Python game with my LLM. I just say this, and it gave me 100 lines, and this is correct. It plays Snake, for example. Okay, so for like in the order of magnitude 100 lines, we are there yet. I think here you need 1000 lines, and it's getting a bit messy. I don't see it do everything correct. It will make bugs in the UCI protocol. It will mess up something in the evaluation. I can't see it do a correct program. But it's not completely out of scope. Maybe in a few years they can write 1000-line programs correctly yet. They are already, I think, in the order of 100.
I think I have to ask the question because it is too good of a pun. Do you plan to write a Go engine in Go? So the Go game.
Okay, no. Go is harder. Go is a harder problem because the tree explodes more, and DeepMind actually with AlphaZero or cousin of AlphaZero had a program that beat Go world champion just a few years ago. There's a documentation about this on YouTube. It's a nice thing. It was a few years ago, like not more than 10 years ago. Sorry?
It's AlphaGo.
AlphaGo. It's kind of the same trick as AlphaZero, of course. I think it's really the same basically. I mean, it will be another incarnation, but it's really the technique from AlphaZero. I think AlphaZero is the generalization of AlphaGo and other board-playing games. And this was actually, if you think about it, with this traditional approach, they bet Kasparov in chess in '97, but it took until, I don't remember, 2015, 16, 17, I don't remember, to beat the Go champion. So this is actually a harder program, and with this very simple research I could not do anything probably. So I also don't play Go, so I will not do that. But certainly there are Go engines in Go.
Anyone else?
A question about Go language. When you compile, it will write
An executable.
Yes,
Yeah.
but it does not require virtual
No.
machine. So it's native code.
Go build, and you get the executable.
Simple execute, static compiler.
This is statically linked, so the of course this is too small. I can't, as usual, I can't zoom anything here. I can't zoom it. If you do file mochi, it will say this is just an executable. Here this is very small. I will copy it and zoom it in. I'm very short-sighted, so I don't see anything. You see, this in this case this is a Mac, so it's a Mach executable ARM, and yeah, it's statically linked. It tends to be no, ls does not work here. It tends to be a bit large. So if you compile Hello World on Linux, for example, you get an executable that is already a megabyte or so, because it's statically linked. Everything is inside the binary. For example, here, this is 2.8 megabyte, and it has everything in there. So the runtime logic of Go is in there, but it's compiled.
Okay.
It's compiled at compile time. It's not a just-in-time compiler.
Okay, it's not the that.
Yeah.
Okay. And you can compile now, for example, for Windows.
Yeah. I can set these variables. I don't remember them, but they are like Go Arc and Go OS, something like that. Go Arc. I can say go arc x86 64 and go OS, I don't know, Linux, go OS equals Linux, and if I then do go build, it will build Linux executable. Now it says it does not know Linux x86 64 because probably I did the wrong thing. But it's, yeah, I'll show you. Otherwise, you don't believe me. Let's say go arc and go OS. The variables I did correct, but the exact name, all possible go OS values. Let's see if there's a list somewhere. Okay, so Linux is correct, and it's called AMD 64. Okay, that was the mistake. So Linux was correct, and the architecture is AMD 64. Let's do it again. Go build. Okay, now we should have file mochi. This is now a ELF executable. You see, I can, if I move this to a Linux machine, as I don't have the alias here, which Linux machine I have access from here, SFTP, which machine I have access to. Let's try this one. Jump. This should work. Yeah. Put mochi. Okay, SSH. I will do it in the terminal now because you can't see anything here. I moved it to this machine here. This is a Linux box. I need to jump because of the firewall. I uploaded it here, and you see I can run it. Okay, I need to change mod 77 mochi. Mochi -v. Here you go. This is the one I just compiled over here. So this is really great. I can also do mochi position start pause go. Yeah, it this is the night that jumps out. Now run on Linux after compiling it with just setting the environment variables. This is really cool. You can do it in any platform for any. It's really completely transparent. You can compile any combination. So this Java thing, write once, run everywhere. This is old. Everybody can do this. And you don't need a JVM or something. This is really compiled at compile time, not just in time compiled at runtime, as is Java.
You talk about the good parts of Go. What are the parts that you dislike a bit more?
Okay, that is a tricky question. The part I dislike, I dislike one thing. This is very specific though, very, very specific. You know, operator overloading, where you can say I redefine my plus to add anything, my object, I define an add method, and then I can use plus to add things. Go does not have that. Now you say, well, who cares? Who uses this? But this is actually quite bad for if you do math. It's quite bad because Python has this, and of course Python rules with NumPy, etc. Because you have these NumPy arrays, you can use the built-in operators to handle, and this is something really missing to Go. There are numerical packages, but they are cumbersome to use because you need to call functions. But this is quite specific. This is if you want to do something like NumPy in Python. I don't think that a lot of people have this complaint, but yeah, it's there. Might I add another complaint? there is no basically if you want to do databases, it's always a little bit messy. For example, Python has SQLite built in, so if you want to just use SQLite, go ahead, do it. Go is lacking a little bit there. You need to have a third-party package, even to use like SQLite and so on. Maybe the dependencies is a little bit. Python has more. Python has this batteries included thing, and I think Go is missing some batteries. Oh, how many questions you have?
No, quick. Is the algorithm deterministic? Or have you cases
yeah,
which the ranking
no.
the same for
Yeah.
more,
No, of course, the search depth is limited. It is very simple, and of course, you have symmetries where two moves have the same evaluation. So I added a small random value, so that if two moves are equal from Moji's point of view, it will pick a random one. Otherwise, it's a bit bad because if you play the same thing, it always also plays the same thing, and it's a bit stupid because then you can play it a few times and you know how it will answer, and you can trick it, and it's better to have a little bit of randomness.
It seems that there are no other questions. So if you go back to my presentation, I just
Absolutely, I will do that. Okay, take the.
So after the discussion, I will come shortly to the upcoming events. Next time we will see us in the next year, the 9th of January, same times. It will be Luca Rainone talking about developer experience for business in companies. And I'm already curious to hear you, Luca. He is already here. So if you are interested, just feel free to go on the NOE website under the events, and you already find all the information, also the registration link. And also we are still looking for talks for the 2025. I have still 5 slots free. So if you have a topic you would like to present or something you would like to discuss with the community, feel free to drop me an email, and I will be happy to find a slot and define everything with you. Apart of that, we see us next time in the next year, so we don't see us before Christmas, so I wish you all a happy Merry Christmas and a Happy New Year. And thank you for coming here. Thank you, Chris, for your presentation. It was
Welcome.
interesting to see how a chess engine can be done in Go. And see you soon. Thank you all.
You're welcome.